Good afternoon, class. We are looking at practice test number 4, module 4, covering sections 5.4, 8, and 9. Here's chapter 9, system of linear and nonlinear equations. Again, we start with the pledge. When we take the exam, we take the exam on our own. If the system of linear equations results in two parallel lines, the system is an inconsistent system. The system has no solution. The graphs are parallel lines. They have the same slope but different y-intercepts. So here's an example. M1 equals to M2, B1 is not equal to B2. So if you were to solve it by any method, you end up with a, like, for example, substitution method or addition method, you end up with a contradiction such as 0 equals 7 indicates the system has no solution. The system is inconsistent. If the system of linear equations results in two intersecting lines, the system is consistent with independent equations. The system has a single solution. At the point of intersection, the graphs are different. They have different slopes. This is the example. Simply put M1 not equal to M2. Finally, and if the system of linear equations results in a single line, the system is consistent system with dependent equations, or in short, just a dependent system. The system has an infinite number of solutions. The graphs are identical. They have the same slope and same y-intercept. So ultimately, the lines are on top of each other. If you solve them for y, they become identical. Not only M1 is equal to M2, also B1 is equal to B2. And if you were to solve it by any method, an identity such as 0 equals 0 indicates the system has an infinite number of solutions. The equations are dependent. We want to solve this system, minus x plus 2y equals minus 1, 5x minus 10y equals 6, and you can do it by any method. One simple method is the addition method. So because we want to add them up such that either the x or y becomes 0, their coefficients must be opposite. Let's multiply this one by 5. And this becomes minus 5x. This becomes plus 10y. This becomes negative 5. And the second one doesn't change. Obviously, these two cancel each other. These two cancel each other. So we get 0. But these two add up to 1. Is this a true statement? No. Because it's a false statement, therefore, this is an inconsistent system. The solution to this system is an empty set. This is phi, a Greek letter that represents an empty set. What about this one? Let's solve in a manner that either x or y have opposite coefficients. For example, if you want to do the x, you can multiply this one by 5, this one by 2. If you want to get rid of the y, you can multiply this one by 3, this one by 7. Either way makes no difference. So if we multiply this one by 3, we get 6x minus 21y equals 9. And if you multiply this one by 7, you get negative 35x plus 21y equals 49. Therefore, when we add them up, these two cancel each other. These two add up to negative 29x, and these two add up to 58. And we divide both sides by negative 29, we get minus 2. We put it in one of the equations. It doesn't matter the first or second one, one of the original equations. For example, equation 1 would be 2 times negative 2 minus 7 times y. And of course, minus 4 moves becomes 4, and y becomes negative 1. It is extremely important. Since we used equation 1 to come up with the pair, you check it with the remaining equation, in this case, equation number 2. So minus 5 times minus 2 is positive 10. 3 times negative 1 is minus 3. They add up to 7. So you should check, and it literally takes seconds. Matrices. A rectangular array or table of numbers. That's the definition. A matrix with m rows and n columns has dimension m by n. So we have 1, 2, 3, we have m rows. We have 1, 2, 3, n columns. So I normally represents the row, J represents the column. So Aij, for example, A11, A22, A12, and so forth. A square matrix has the same number of rows as columns. The dimension of a square matrix is n by n. We can add matrices with the same dimension, and that's the key, everybody. So if I want to add them up, I just add up components, 5 and negative 4. We get positive 1. Minus 6 and 6, we get 0. 8 and 8, we get 16. 9 and negative 3, we get positive 6. That's how we add it. The product AB of an M by N matrix A and N by K matrix B is an M by K. So first I want to make sure we understand what happens here. So this has M rows, N columns. The other one must have N columns, otherwise you can't multiply. And then the resulting matrix will get the number of rows from A and columns from the second matrix, B. So first and foremost, check the dimension. As you can see, this is 2 by 3, and this is 1, 2, 3 by 2. The result would be 2 by 2. 2 by 2. How do we multiply? We multiply this row by this row, by this column, my apologies. So negative 3 times negative 6. 4 times positive 2, 2 times 3. Add them up. This is 18, this is 8, this is 6. They add up to 32. So the first row by the first column gives you the first entry, A11. Now we multiply it by the second column, it gives us this entry. Negative 3 times 4, 4 times 3, 2 times negative 2. Obviously, these two cancel each other, we get negative 4. So the first row by all the columns give us the first row of the resulting matrix. Now the second row by every column gives us the second row. So for example, now here I get 5 times negative 6, 0 times 2, 4 times 3. So this is minus 30. This is plus 12. I get minus 18 here. And I'm going to leave this one for you to multiply this one and this one to get this one. And so we get minus 18 here. I want you to show this is 12. I think by now you know how to handle it. Matrix method to solve systems of linear equations. REF, row echelon form method. Apply row transformation to get ones along the diagonal. A leading coefficient is 1 and zeros below the augmented matrix. Or REF, reduced row echelon form. Here's the method. Apply row transformation to get ones along the diagonals and zeros both below and above the augmented matrix. Below and above, uh, the augmented matrix, every leading one is to the right of the one above it, and any non-zero rows are always above rows with all zeros. Let's make some sense out of this. Here's a system we want to solve. Minus x plus 2y equals minus 1, 5x minus 10y equals 6. And I hope you remember that we just did that. But I want to go with the matrices. In other words, I'm repeating question 2a. Now, the coefficients of x and y, minus 1, 2, 5, minus 10, that's the coefficient matrix. The result, okay, the last column, okay, the solution column is minus 1, 6. So here's how we deal with that. The augmented matrix is the coefficient matrix and the solution matrix. So it might be easier to look at it column-wise. Minus 1 and 5, 2 and negative 10. This represents the equal sign. So I'm going to write this is the coefficient matrix. This is the last column representing the constant, the solution. Each column on the left represent a different variable. So x variables, y variables, those are the coefficients. This represents an equal sign. So to solve this, the first step to make this 1. And remember, this row represents this equation. So if I have an equation, I can multiply it by any number except, of course, 0. So if I want to make this positive 1, I'm going to multiply everything by negative 1. In other words, minus R1 replaces R1. This is the notation. So that means you don't change the second row. The first row becomes positive 1, negative 2, positive 1. Now, you do it in this order. First, you make this one 1. Then everything underneath is 0. The reason I say everything underneath, there may be like 10 rows. Doesn't matter. It's only 1. So we want to make 5, 0. But again, let's say there is another one. There is another one. There are 4 of them. First, you make all 4 1 by 1, 0, and then you move to this number in the diagonal. So you work with the diagonals. The first one, you make it 1. Everything underneath, you make it 0. Then you go to the next entry in the diagonal. So how do I make this 5, 0? You can't just add or subtract numbers. You understand? A row represents an equation. So this is a new equation. I can multiply this one by 5 and subtract it from this. So I can say row 2 minus 5 R1 or minus 5 R1 plus row 2 is the new row 2. I hope everyone understands what this means. Okay, so you write the first row unchanged. Now you're going to multiply this one by 5 and subtract it. That's the meaning of minus 5 R1. So this becomes 0. If I multiply this by 5, or better yet, minus 5, I get positive 10. With this one, it adds up to 0. Multiply this one by 5, subtract it from 6, I get 1. And Here's what happens when a row is all zeros except the last entry. The corresponding equation for the last row is 0 equals 1 because this is 0x plus 0y equals 1. This one, everybody, 1x minus 2y equals 1, which is a false statement. A row of all zeros except the last entry, therefore, the system is inconsistent and the solution to the system is an empty set. We're done. I want to show you how the graphing calculator can do the job, for example, TI calculator. You go to matrix editor. Matrix editor found by pressing second and x to the power of -1. Use the arrow keys to the right to edit the dimension you want and press enter. Put all the entries using the arrow keys, press enter. Okay. And then how to solve a system. I'm going to go to that in a moment. First, you put matrix A, it's 2 by 3, and then you enter. This is a 2 by 3. You enter all those entries. As you can see, -1, 5, 2 minus 10, and this -1, 6. Now, to solve it, you can do row echelon form, or you can use reduced row echelon form. So how to solve a system by matrix? Row echelon form. Matrix editor found by pressing second x to the power -1 math. Then A, the first one is REF. Okay. And pressing second x inverse, enter, brings up matrix A, and then enter. In other words, REF matrix A gives you this one. Now, the reason the first column may be different because the methodology by which they made it one may be different. But the fact that the bottom is 0, 0, 1 indicates the same answer, namely a row of all zeros except the last entry. The system is inconsistent. I want to look at the 2b, and I'm going to write the augmented matrix. That means matrix 2 minus 7, 3, that's the row, minus 5, 3, 7 is the row, and a line segment. If it's easier this way, 2 minus 5, minus 7, 3, 3, 7. And so the first order of business is to make this one 1. So I can multiply everything, this whole thing, by 1/2 or divide by 2. And that works fine. I want you to know that. Sometimes when you introduce fractions, dealing with adding and subtracting matrices becomes very difficult. So one way to avoid that, you can make this 6 by multiplying it by 3, and then add this one to it, becomes 1. So I'm going to write 3R1 plus R2 is equal to R1. That's why the entry that you come up with to begin with may be different than the next person, okay? Because there are various ways to make this one 1. Another one would be half of that. So if I multiply this one by 3, I get 6. And I add this one to it, I get 1. Again, bear in mind, this is not changing. We're going to repeat the bottom. So what happens here? I'm going to multiply by 3. I get negative 21. I add 3. I get negative 18. 3 times 3, 9 and 7, 16. So just in case, I want to make sure we understand what happens here. So how did we get this? Okay, we're going to write 3 times negative 7 plus 3. How do we get here? 3 times 3 plus 7. Okay, just to give you an idea. So the next step is to make this guy 0. So I'm going to rewrite the first column. Now, how do we get this one to a 0 if we multiply this one by 5 and add to it? So we're going to say 5R1 plus R2 is the new R2. So the first one repeats. And the second one, this is obviously 0. Now 5 times negative 18 plus 3. Okay, so 5 times negative 18 is negative 90 plus 3 is negative 87. The last one, 5 times 16 plus 7, 80 plus 7 is 87. So this is the new. Now, the last thing is to make this guy 1. So divide everything by negative 87 or minus 1 over 87. R2 goes to R2. So with that being the case, this goes to 1, this goes to negative 1. And please understand, this is the answer. 0x, let's just write it, 1x minus 18y equals 16, 0x plus 1y equals negative 1. Obviously, this means this is the answer, y equals negative 1. This means y equals negative 1. Now, reverse substitution, back substitution, you put it in. 18 times negative 1, minus 18 times negative 1 is positive 18. Move it to the other side, subtract it, you get minus 2. Okay, and the answer is minus 2 comma negative 1. What I want to show you, I want to show you also how to work with matrices. So working with matrices, we're going to put 2 by 3, and we're going to put this row and this row. And we're going to do REF. Now, again, their REF is different than ours. But if you look at the bottom page, you see that y equals negative 1, and you can put it back. Now, I'm going to also do RREF. If I do RREF, even this one becomes 0. So now y is negative 1, x is negative 2. Okay, so that last column is the answer. Use Kramer's rule to solve the system. So we want to discuss a different methodology. What is Kramer's rule? We want to discuss determinants. What is a determinant? The determinant of a 2 by 2 matrix, if it's in the form of A, B, C, D, is their cross product. Okay, AD minus BC. This minus that. That's by definition. So, and the notation is looks like an absolute value. This means determinant for a matrix is the determinant of a 2 by 2, which is AD minus BC. So Kramer's rule for two equations containing two variables says, if we have ax plus by equals s and cx plus dy equals t, first of all, everybody understands A, B, C, D is the coefficient matrix. Okay, so that would be the denominator. And now, when you want to solve for x, this column changes to st. When you want to solve for y, this column changes to st. Take a look. This, everybody, A, B, C, D, this is the coefficient matrix. They call it D. D sub x, the first column, AC is changed with the constant. If you want to solve for y, so the bottom, of course, doesn't change. The numerator, the first column doesn't change. The second column changes. This is D sub y divided by D. So, for example, here, let's just write the coefficient matrix. So determinant of A, B, C, D is AD minus C. Note, we replace the first column D by the solution matrix for D sub x, and we replace the second column D by the solution matrix for D sub y. Also, if D is 0, if the denominator is 0, and at least one of the determinants, D sub x or D sub y or D sub z, because there might be like 3 or 4, is different from 0, then the system is inconsistent and the solution set is an empty set. If D is 0, and all the determinant, d sub x, d sub y, d sub c, because you may have a 3 by 3 or 4 by 4 and so forth, are equal to 0, then the system is consistent and dependent. So a quick recap of that. If by any chance this becomes 0, if any of the top is not 0, it's inconsistent. If all the tops, because we have 2 or 3 or 4 different, variables, if each one is 0, then it becomes dependent. So for example, here, I hope you recognize that let me just write this. The coefficient matrix is 2 minus 5 minus 7, 3. So the determinant would be the product, the cross product for this one. So 2 times 3 minus negative 5 times negative 7. And we get negative 29. Now, we write the same thing. For d sub x, we change the first column to 3 and 7. And we do the cross. 3 times 3 minus 7 times negative 7. Okay. 49 and 49 and 9 is 58. I can write that. Erase my work. Now, d sub y, I go back to this d, and the second column, the y column, I'm going to change it to 3 and 7. This is 58, 3 and 7. So the cross product, 2 times 7 minus 3 times negative 5. This is 14 plus 15 is 29. And we're going to divide d sub x by this one. We're going to divide d sub y by this one. D sub x divided by d, 58 divided by negative 29 is negative 2. And y is d sub y, which is 29 divided by a negative 29, which becomes negative 1. And that's the same answer that we got before. The differences we are using Kramer's rule. All right, what happens when we have more columns and rows? And of course, determinant is only for a square matrix. So you can evaluate the determinant by expanding it with respect to this column, this row, this column. Any of them makes no difference. But the methodology is the easiest way, just find the one with the more zeros. The general case is A11 all the way to A13, the first row, the second one, the third one. So if we want to expand it with respect to this one, so if we want to expand it with respect to this one, so first we drop this row and whatever is left, so A11 times that. I just want you to pay attention to this one. What is this one? A11 times what you see here. Now, for the second one, we drop this and we change the sign. They alternate. This has a positive sign, negative sign, positive sign. So for this one, A12 and negative times, look, A21, A23, A32, A23, and the last one is you drop this one and this is what's left. That's how you do that. Okay, let me actually show you that one also. For the last one, we are expanding with respect to this. You drop this one and notice A13 and then the matrix of that one, because we know how to calculate the matrix for a 2 by 2. So here's what happens, everybody. The 2 by 2 determinants are called minors of the 3 by 3 determinant. For example, this is called M for minor, 1, 1. What is M1, 2 is this one. What is M1, 3 is this one. Now, if we include the sign, and the sign alternate because, and there is a methodology for that, and it's called the cofactor. The cofactor of a matrix is obtained from the minor of the matrix and is equal to the product of -1 to the power of I plus j and the minor of the matrix. In other words, never mind A11, this has a positive coefficient. This one, the negative coefficient comes from here. And this one has a positive coefficient. Now, how do they come up with that? If you go with I plus j, this one, 1 plus 1 is 2, so that becomes -1 to the power of 2 is positive. This one, 1 and 2 is 3, -1 to the power of 3 is negative. That's why it's negative. This one, A1, 3, 1 and 3 is 4, -1 to the power of 4 is positive. The reason I mention that, because if you pick something else and do the job, it's important to know what you begin with. And as long as you find the first one, then the rest of them, alternate. Now, I'm going to choose the first row to expand, but honestly, the best course of action would have been the second column or the second row, because it has zeros, because these numbers become zero, you don't have to worry about it. But I just wanted to work it out from the scratch. So we are going to expand it with respect to the first row. So this one would be 5. Let's just do this first. So this one will remain, right? So if I want for the first one, I'm going to use a different color. So I'm going to drop this one. So this becomes 5 times this matrix, this determinant, okay? Then it alternates -8. Now I'm going to multiply the -8. I'm going to cross this column out. So -8. And this one, 3 minus 5, 4, 1. Okay. And finally, again, we always drop this row and this last one now, of course, positive, negative, positive, or just go with -1 to the power of I plus j. +6 times what is left, this one. See, 3, 0, -5 minus 2. So it's very straightforward. Now let's calculate each determinant. This one, AD minus BC, okay? 0 times 1 minus -2 times 4. That means 0 minus 8. This one, 3 minus -20. This one, -6 minus 0. So this is +8. This is +8. 23, 6 times -6. And they add up to 40 plus 184 minus 136, and it's 188. So when you have a 3 by 3 matrix, you do it this way. It's important to understand the concept. Of course, ultimately, you can use a calculator, but I want to show you some easy ways out also without the calculator, and then I go show you with the calculator. So we are repeating the same question. Here's the second method. So you put another matrix next to it. So in general, you put 2 of them next to each other. You start from the very first entry, you go diagonally, multiply, and add them up. Then you start from here, the first one, you go diagonally, multiply, add them up, and subtract the red ones from the blue ones. Okay? Now, do you have to memorize this formula? No. Let's put them next to each other and see. So first, we're going to go this way, okay, and this way. Those 3 arrows. So what is this? 5 times 0 times 1 plus negative 8 times 4 times negative 5 plus 6 times 3 times negative 2. So that we add up. Then we go with the very first entry for the second one, and we go diagonally in the opposite direction. Okay. Now, this way or that way, either way. Now you multiply these three numbers. 5 for negative 2 plus negative 8 times 3 times 1 plus 6 times 0 times negative 5. So this way, multiply, add them up. This way, multiply and add them up. Subtract the result of the red from the blue. 124 minus 64 is 188. You can check it out if you want. It's a lot faster than what we did in the previous page. The note I want to add is very important. It is easier to expand across any row with most number of zeros. So again, that would have been better if we wanted to do it with respect to the second row or second column. You can try it. Now, if you go with the calculator, matrix 3 by 3, you enter it. First, you enter the 3 by 3 matrix. Then you say, okay, find determinant of B, and it gives you the answer in a split second. Again, you should know how to do this by hand, and if need be, when it gets complicated, you do it with technology. All right, we want to solve this system. First, I want to show you how easy it is to do it by hand, and then we do it with technology because it's a 3 by 3. So, first of all, we're going to give them a number, equation 1, equation 2, equation 3, so we can go back and forth. And the very first thing we notice, equation 1 and equation 2, we can combine them, equation 1 and equation 2, because these two cancel each other. So if I add equation 1 and 2, I get 5x plus 3z equals a positive 1. Now, so I used equation 1 and 2. Now, I have no choice but to use the one I haven't used, which is equation 3 must be used. Do you use equation 1 or 2 with that? That's your choice. But equation 3, you have no choice. However, take a look at this one. Because you got rid of the y, you have to get rid of the same variable y. So because this is minus 4, this is 3, you're going to multiply this one by 4, this one by 3. Okay. So if I multiply this one by 3, I get 9x minus 12y plus 6c equals minus 45. If I multiply this one by 4, I get 8x plus 12y plus 20z equals 80. So a quick recap before we continue. We used equation 1 and 2. We have no choice but to use equation 3. Number 1. Number 2, we got rid of the y. We have to get rid of the same variable y. And now these two cancel each other. You get 8 and 9, 17x, 6 and 20, 26c, negative 45 and 80, 35. So equation 1 and equation 5, both of them have just x and z. So let's put equation 5 next to it. And let's get rid of one of the variables. It doesn't matter which one you want to get rid of. So if you want to get rid of x, you can multiply this one by 17, this one by negative 5. If you want to get rid of the z, this one by 26, this one by 3, one of them negative, okay? So let's get rid of the x, 17 and negative 5. So if you multiply 17 times 5, 85x, times 351z, times 1 is 17, minus 5, minus 85x, minus 5 times 26, minus 130z, and this is minus 175. When we add them up, the two cancel out. We get minus 79 z equals negative 158. And z becomes 2. Now, you have to go back to either equation 4 or 5. For example, equation 4, 5x plus 3 times 2 equals 1. So this is 6. Take it to the other side, becomes negative 5. Divided by 5, you get negative 1. Then you go to one of the original equations. For example, the first one, 3 times negative 1 plus minus 4y plus 2 times 2 equals negative 15. And I'm going to leave it for you to show that y equals 4. And therefore, the answer would be negative 142. Again, what did we use? We used equation 1. You must check with equation 2 and equation 3. You must. It doesn't take long to check that it works or not, just for the sake of argument. 2 times negative 1 is negative 2. 4 times 4 is 16. And z is 2. 2 and negative 2 cancel each other. We get the 16 back. And you can check the third one. Now, I'm going to use the same question. And I'm going to write the augmented matrix, which means if I go column-wise, that means 3, 2, 2, minus 4, 4, 3, 2, 1, 5, negative 15, 16, 20. So take a look at the augmented matrix. Now, we can do the matrix transformation, and we can put it into a calculator, not necessarily do it by hand. So here's what happens. We put the 3 by 4 matrix into a calculator. And since we have only 3 columns, I'll show you the fourth one also, okay? There wasn't enough room to show it here. Then we say REF, row echelon form, and I call this B, the matrix. We have a few choices there. You have a few matrices. You have A, B, and I believe C. But in any event, this is what we get. And obviously, you have only 2 columns. I'm going to show you the other 2 columns. Okay. You can keep it as that. I'm going to change the answer to fractions. It becomes more manageable. And I'm going to show you what this means. Obviously, the last one means z equals 2. This means y minus 1 over 20 at z equals 39 over 10. And this means x minus 4 thirds y plus 2 thirds z equals negative 5. And you can solve that by back substitution. However, I'm going to go with REF, because when I go with reduced row echelon form, the last column is my answer. Minus 142. We already had that. All right, we want to solve this system. There are several ways of handling it. If we multiply this one by 8 and add it to this, let's see what happens. If I multiply by 8, I get 16y plus 24z equals negative 112. And if I add them up, these two cancel each other. These two cancel each other, but they add up. So we get 0 equals negative 224, which is a false statement, and therefore there is no solution. If we were to do this, with a calculator, we put the A in, we do REF or RREF. In both cases, look at the last row. All of them are, all entries are 0, except the last one. The corresponding equation for the last row, 0 equals 1, because 0x, 0y, 0, z. 0 equals 1 is a false statement, a row of all zeros, except the last entry. Therefore, the system is inconsistent, and the solution to this system is an empty set. This is an empty set, or this is an empty set. This is a notation for an empty set, everybody, okay? So I hope everybody's okay with that. Let's look at this system. Let's solve it by hand. This is 3, so why don't we multiply the first one by 3 and see what happens. This is minus 3x, minus 9y, minus 6. These two cancel each other. These two cancel each other. These two cancel each other. 0 equals 0 is a true statement. Therefore, it's a dependent system with infinitely many solutions. When you want to write a dependent system class, normally you write x, and for example, in this one, if you solve for y, that means negative 3y is move the x minus 2, then divide this one by negative 3, this one by negative 3, this one by negative 3, and you get this one. So I hope everybody's clear on that, okay? And so there you have it. When we have a dependent system with infinitely many solutions, normally we use one of the variables and the other one is now, if I put it into a calculator and I do REF, so notice that row 2 is negative 3 times row 1. By the way, if one row is a multiple of another one, that takes care of the business. If I do REF or RREF and one row is all zeros, the corresponding equation for the last row, 0 equals 0, is a true statement. A row of all zeros, therefore, the system is dependent with infinitely many solutions. So I hope everybody's clear. So that all of them zeros, dependent. The last one is not, inconsistent. How do you solve this? We solve it in the same manner that we did with addition system. So I hope you see that we can add them up. These two cancel each other. We get 4x squared equals 28. That means x squared is 7. That means x is plus minus square root of 7. You put that into one of the equations, for example, equation 2, and because x is being raised to the power of 2, positive or negative makes no difference. This gives you 7. Subtract it from 16, you get 9, and y becomes plus minus 3. And I hope you see that this means 4 solutions. They are both negative, or one of them is negative, or both positive. Minus square root of 7 minus 3, minus square root of 7, 3, square root of 7 minus 3, square root of 7, 3. And you have to check. Now, how do you check that? We use the equation 2. You have to check it with equation 1. So I'm going to check one of them. Okay, for example, the first one, I put it into this. 3 times equation 1. 3 times negative square root of 7 quantity squared minus negative 3 squared. So this one is 7 times 3, and this one is 9, so minus 9. 3 times 7, 21 minus 9 is 12. It checks. So I did one of them. You can figure out the rest of them in the same manner. Graph the system of inequalities. Well, just ignore the system and do one by one. How do you do it? The way you graph any inequality, you just change it to equality. And for this one, you want two pairs, normally x and y intercept. I hope you realize if x is 0, y is minus 2. If y is 0, x is 1. This one, if x is 0, y is 3. If y is 0, x is 2. So those are easy points. I hope everybody can graph the two. So we have 0, minus 2, 1, 0. That would be the red line. Why is it dashed? We don't have equality. 0, 3 is here. 2, 0 is here. And it's a solid line. Why is it solid? Because we have the equality. And now you pick a test point. Okay, so this is the red line, this is the blue line. 2x minus y equals to 3x plus 2y equals 6. You pick a test point. The easiest point would be 0, 0, as long as 0, 0 is not on the line. You can check it for the line that it doesn't belong to. Okay, and so you go back to the original inequalities. So this is the test point. And now if I put 0 for x and y, 0 less than 2, true statement. 0 larger than or equal to 6, false statement. So the first one is a true statement. And for the red one, this works. That means this side works. For the red one, 0, 0 is included. So never mind the blue line. For the blue line, it's a false statement. So that side does not work. It's the opposite side that works. Now the red and blue shaded region, they come together right here. So here's red, here's blue. This is where everything comes together, and that's where the solution is. Graph the inequality y is larger than x squared plus 1. So we graph the equality y equals x squared plus 1, which is a parabola up by 1. So everybody knows the graph, a parabola here and then up by 1. This one, okay, obviously. Okay, that's 0, 1. You pick a test point not on the graph, but somewhere. For example, 0, 2. It's right here. And you see whether it works or not. Replace the x with 0, y with 2. 2 is larger than or equal to 0 plus 1. 2 is larger than 1. True statement. So that works. Everything inside works. What about the parabola? Look at this one. We don't have the equality. The parabola itself is not included. Okay? That's why it's dashed. So pick up a test point, check it out, figure out the region of interest.